Today's lesson is all about probability. So there's a few different types of probability you're going to see. And it's going to be a little bit long video because there are 5 slides. So I'm going to try to do my best to go quick, but to explain it well. So the first one is called experimental probability. This is where you conduct an experiment and figure out what the probability or the likelihood of your outcome would it be. So my situation is a bag has 6 marbles, has a bag of 6 blue marbles, 3 red marbles, 2 green marbles, 17 yellow marbles, and I'm going to pick a marble and record it and place it back into the bag and do this 17 or 10 times. So I did this below. So as you can see, I color coded what I picked. So now I'm going to fill it in here. So blue marbles, how many did I pick? Well, it looks like 1, 2, 3. So I'm going to put 3 here. How many red marbles did I pick? Just 1. How many green marbles did I pick? Just 1. And how many yellow? Looks like 1, 2, 3, 4, 5. Okay. So now what is the probability I got that color? So remember that we're going to write it as a fraction, but it's the number that we have out of how many total. So I only had 10 chances. So I got 3 out of 10 for the blue because I picked 3, but I only had 10 tries to get it. Red one, 1 out of 10. Green one, 1 out of 10. And the yellow one is 5 out of 10, which reduces down to 1/2. So it's saying half the probability of me picking a yellow marble is 50-50 chance, pretty much. All right, so now let's look at the other type, theoretical probability. So theoretical probability, it's the same problem as before, but this is really what's happening. So what are your odds of picking these if you just have them in a bag? So the first thing I'm going to do is, what is the probability of getting a blue marble? Well, I have 6 blue marbles in the bag, but how many marbles do I have total? So 6 plus 3 gives me 9. 9 plus 2 is 11. 11 plus 17 gives me 28. So I have a total of 28. So how we write it is the number of marbles you have that we're looking for. So I'm just going to write the number marbles looking at divided by the total number of marbles. Okay, and I'm going to underline it to make it the division because we need it to be a divided sign. Okay, there we go. So in this case, this is what we're going to use for general for all of these. In this case, specifically, the number of marbles I'm looking at, well, I'm looking at the blue marbles. I have 6. Oh, and I don't want that, so let me fix that. So I have 6 out of, we said 28 was the total. So I have 6 out of 20, which reduces down to, 2 goes into them, so 3 divided by 14, right? Okay. What is the probability of getting a red marble? Well, I have 3 red marbles, so 3 out of 28 again. What's the probability of getting a green marble? Well, we have 2 green marbles out of 28, and this can be reduced down to 1 out of 14. What's the probability of getting a yellow marble? 17 out of 28, and that can't be reduced anymore. So that's the probability for theoretical. Now, we also will see things with Venn diagrams. All right, so this is a good way to do something where you're comparing two things, where you have a combination of things where they overlap in something. So I like to think of it as that. So remember, one circle represents something, the other circle represents something, and where they overlap is what they have in common. So in a group of 30 students, so we have a total of 30 students, there are 14 girls, which are represented with the yellow, and 4 of them can speak French. So 4 of them are inside the combination, because in the circle, or where they overlap, is that's who can speak French. 6 of the 16 guys, so we have 6 blue in here, and 16 blue total, can speak French also. All right, so let's look at the questions. If a student is selected at random from the group, find the probability that the selected student can speak French. So remember, this inside right here are the ones that can speak French. So I have 1, 2, 3, 4 girls. 1, 2, 3, 4, 5, 6 boys. Well, 4 plus 6 is 10. So I have 10. Okay, maybe it will let me type in here. There we go, 10. And what's the probability? Well, 10 out of, we said there's 30 students, so 10 out of 30, which equals 1/3. All right, so the next one. If a student is selected at random from the group, find the probability that the selected student is a boy. Well, the blue ones are the boys, so we have 16 boys. What's the probability? 16 out of 30. This can be reduced, divide 2 into it, so we get 8 divided by 15. Okay, so 8 out of 15. If a student is selected at random, find the probability this selected is a girl. So the girls are the yellow, so we have 14 of them. So we're going to put 14 in here, and 14 out of 30. This also can be reduced by dividing by 2, so we get 7 out of 15. All right, the last question. If a student is selected at random from the group, find the probability that the selected student is a girl that speaks French. So now we just want the girls that speak French. Well, in this case, there's only 4 of them. So I'm going to put 4 here. 4 divided by 30, because it's still out of the total group. And that will give us 2 out of 15. All right, so we've reduced our fractions and we found our probabilities. The next type of probability is called a combination. So what is the combination, or what's the possibilities of something, and order doesn't matter. So it doesn't matter. So think about a pizza. If you're going to order a 2-topping pizza, here's the available toppings: extra cheese, pepperoni, mushrooms, pineapple, and olives. So it doesn't really matter the order of the topping. We just want to know what the combinations we could possibly get. All right, so first choice, we're going to have extra cheese, and then with extra cheese we could do pepperoni. All right, or we could have extra cheese and we could have mushrooms, or we could do extra cheese and we could have pineapple, or we could have extra cheese and we could have olives. Okay, so that's one set of combinations we could do. Or let's move to the next one. If we have pepperoni, okay, or we could have pepperoni and we could have mushrooms on it. Okay, we could have pepperoni and we could have pineapple, or we could have pepperoni and we could have olives. All right, or the next choice we could have is mushrooms and pineapple. We have mushrooms or olives. Okay. Or the next one, we could have just pineapple and olives. All right, so those are the combinations we could have. We have a total of, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many different choices can we have, or how many 2-topping combinations can a customer choose from? 10. There's 10 different combinations. What is the probability that a 2-topping pizza will have pepperoni? So I'm going to look and see how many times I see pepperoni. So I see pepperoni here, and I'm just going to shade in the box so you can see pepperoni, 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 and pepperoni. All right, so we have 1, 2, 3, 4 times out of 10, because 10 was our total, which would reduce down to 2/5. All right, so that's our probability. 2 out of every 5 pizzas would have a pepperoni on it, hypothetically, is what we're saying. So if you order a 2-topping pizza, this is called a combination, where the order doesn't matter. So now we're going to look at what's called a permutation. So I've already uploaded my picture of my permutation trees, is what it really should say, permutation trees. they're combinations, but in math we use the word permutation. So what this means is that order does matter. So it makes a difference what order we go in. So Anne wishes to knit herself a striped sweater. She has 4 colors from the yarn available: red, blue, green, and yellow. And my question is, how many different combinations of the 3 colors does she have to choose from? So remember, the combination can be its specific order. So like the first one, I could do yellow, red, and blue. So that would be the stripes: yellow, red, and blue, and they keep repeating. Or I could do yellow, red, and green. So there's one set of them. Here's another, and here's another, here's another. So we have 4 different sets because we have 4 different colors that we could start from. So I want to know, what is the total? Well, I'm going to count clear out at the edge of my tree. So I have 6 in this one, 6 in this one, 6 in this one, 6 in this one. So I have 6 times 4, which gives you 24. So I have 24 total combinations, okay, to choose from. Now I want to know, what is the probability that I will have red in the sweater? So, I spelled combinations wrong, so I'll fix it. What is the probability of having red? Well, I got to look and see every time I see a red. So I have 1 there, and I think I'm going to circle them so that you can kind of see what I'm looking at. All right, so I'm just going to make a circle. I need to empty it, and I'm going to actually make the outline be red so you can see that it's red. All right, so I have red here, so there's 1. So I'm going to copy, paste it. Where's another red? Well, I see red here. Paste another one. I see red here. Okay, so those are the only reds I see in that one. Paste another circle. Let's see. Oh, I have red here, but this red goes to this one, this one. So there's 6 red here. So these all would have red. So I'm gonna type in a little 6 there. So we have 6 red here. Maybe I'll do that for each slide so I can, or each picture. So I have that 6 there. All right, how many here? I had 1, 2, 3. I don't see any more red, so I'm going to just copy and paste this. Copy and paste. I'm going to put 3 on this one. All right, now let's look over here. Once again, I'm going to take this, copy and paste it. So I have a red here. Paste it. I have a red here. Oh, and here I have a red, but it means these 2 also would have red. So I have 2 extras there. So this combination means that these will also be, so maybe I'll just make 2 giant circles here. I'm going to tilt this one a little bit. Okay, so that would be a combination with red. Tilt this one. This would be a combination with red. Okay, so I have 4 there. And you notice here the same thing I did here, I should have done up here. So this should really be 4. So I'm going to take this, bring this down, and it's 4 there. Let's see if this one ends up being 4. Okay, so I'm going to stretch this out so we can see the circle. Okay, and then I'll copy and paste that one and turn it. Okay, so there's those. All right, so this one I have red here. Yeah, I'm going to see the same thing here as I saw up here. So let's bring this down. So there's 1 there. And turn this. Okay, there's another there. I also see red and red, so I'm just going to have 2 more small ones. So red and red. Now you don't need to circle all these. You can count your combinations on your paper. So I have 4, 6, 4, and I have another 4 up here. So copy and paste 4 here. So all together I have, well, that makes 10. So I have 18 that could have red. So 18 out of 24 could possibly have red for this probability.